Hello, everyone. Our goal for today on these notes, 1.2 Analyzing Graphs of Function Relations, Day 1, is that I can use graphs of functions to estimate function values and find domains, ranges, y-intercepts, and zeros of functions. You're also going to have to be able to find x and y intercepts and zeros of functions algebraically, which was in our algebra review, so it shouldn't be that big of a deal. All right, go ahead and pause the video and try the warm-up, and then I'm going to show you the answers. All right, so here are the answers. The first one is negative infinity to positive infinity, all real numbers. There are no restrictions. Second one, negative infinity to 3, bracket. And then the third one is negative infinity to 0, parentheses, union 0 to 7, both with parentheses, union 7 to infinity. If you have questions on either of these three, you can go ahead and pause the video and ask about the specific problem you have in the Zoom call. Okay, next, stating domain and range from graphs. So this is a good practice. Once again, go ahead and pause the video and try these two on your own, and then we can compare answers and see how you did. Okay, so first one here, domain, you look how far left it goes, which is an arrow. You look how far right it goes, which is a value where it stops. So I'm going to say negative infinity because it goes forever to the left. And then to the right, it stops at 3, but includes 3. All right, now I'm going to say my range. I'm going to say first off the lowest my graph goes. The lowest my graph goes is right here, which is an arrow, and this is the highest my graph goes. So my range is negative infinity, oopsies, negative infinity to the highest value, which is 2, and it's including 2. Now, people always ask, like, how did I know to use a bracket? How do you know it's including? The only way it wouldn't be is if there was an open point right here. If there are open points, then I wouldn't include 2 in mine. So if you saw something that looked like this, that's when you're not including it. Okay? All right. Next. Oh, also, keep in mind if your graph looked like this. This is a tricky graph. Ready? Like this. People will accidentally say the lowest it goes is here when realize this arrow just stopped right here. It just goes on forever and ever, so that would still be negative infinity. Okay. Next one here, your domain. Look as far left as it goes. And then you can see that it stops right here. But what I want you to notice is that there is a value here. So you don't, let me start writing it so you can see what I'm talking about. All right, so I have negative 3, because that's as far left it goes, comma, and then people accidentally put it stops at 1, right? Because they're looking solely at this piece, okay? But there's a value at 1, and it picks back up, so I'm not going to stop right there. And I'm going to say how far, where does it actually stop? It stops right here, which is an arrow, all the way to the right, so that's infinity. So a common incorrect answer is negative infinity to 1 bracket union comma 1 to infinity. Okay, but remember this is contradictory right here. This is saying include 1, but don't include 1. It doesn't make any sense. That means include 1. Okay. All right, last, the range, the lowest the graph goes. That's an arrow, so negative infinity, comma, okay. Let me get these colored parts off here that I still had in there. All right, so then if you look, I'm going to start trying to highlight to show you what I'm trying to say. So the lowest the graph goes is negative infinity, and then it keeps going and going and going. There's still y values here, 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 and then they stop right there. So I'm going to say my y values stop at negative 1, and it's an open point, so I'm not going to include it. But then I also have y values right here. That y value is a y value of 1. So I'm going to say union, and then the y value of 1. I want to use brackets around this because it's including the y value of 1. Okay. Next is estimating function values. So this is, can you look at a graph and read it, basically. So this says the function f of x equals negative 5x squared plus 50x approximates the profit at a toy company where X represents marketing cost and F of X represents profit. So at the input is cost, the output is profit. Both costs and profits are measured in tens of thousands of dollars. Also notice right here that this is a downward facing parabola. That's the equation for it. And this is a downward facing parabola. It's only part of it because the negative values we're not going to be using those if we're talking about cost and profit. Okay, so A says, use the graph to estimate the profit when the marketing costs are $30,000. Okay, so I'm going to put A right here so we can see it. So we're going to use the graph to estimate the profit. So we're estimating profit when marketing costs are $30,000. Remember, it says in tens of thousands. So tens of thousands, I can cross off 4 zeros. So I'm looking for when this is a 3. So I look, here's where it's a 3. I'm going to go up to the graph. Right there is what I'm estimating. Okay, so I want to estimate what number that is. Notice these go by 75. So this is 125 here. So it's more than 100, less than 125, closer to 100. So I'm going to say 105. But then remember, this is in tens of thousands. So I want to put 4 zeros on that. 1, 2, 3, 4. So my estimate is going to be 1,050,000. All right, B. Confirm your estimate algebraically. Okay, so it's asking when X is 3, right? Because this is an input. When X is 3, what is Y? So we're going to plug it into the equation. So we're going to find F of 3. So that is -5 times 3 squared plus 50 times 3. All right, remember orders of operations, this is 9. So -45 plus 150, which is exactly 105, which is what I guessed. So that's nice. So add 4 zeros, 105, 1, 2, 3, 4, and it actually is 1,050,000. If you guessed like 110, you're not going to get it wrong. It's an estimate. It's a guess. If you guessed 126, then it's wrong. If you guessed 100 exactly, that's wrong. Right? And if you forgot to put your zeros on your 4 extra zeros, that's wrong. Okay, next is C. Use the graph to estimate the marketing cost when the profit is 1.25 million. Okay, so 1.25 million, cross off 4 zeros. 1, 2, 3, 4. So I'm looking for 125. So let me change my colors here so we can see this. So 125 is right here. So I'm going to go across right there. This is 5. So my guess is going to be 5 and then 4 zeros. 1, 2, 3, 4. So my guess is 50,000. All right, so now it says D, confirm your estimate algebraically. So let's do that. So when Y is 125, so when F of X right here is 125. So I'm going to do 125 equals -5x squared plus 50x. All right, now I need to solve this. It is a quadratic with an x squared and an x. So I cannot solve by square rooting. So I'm going to get everything on one side. I'm going to get everything on the left side so that my x squared becomes positive. So I'm going to do add 5x squared, subtract 50x from both sides. So my equation is 5x squared minus 50x plus 125 equals 0. All right. So now I'm going to try to factor to solve this first. So first things first, look for a GCF. They have a 5 in common, all of them. So I'm going to factor out the 5. So that's x squared minus 10x plus 5 goes in there 2 times, remainder 2, 5, 25 times. All right, now I'm going to keep factoring here. So I have 5 times, and then 2 numbers that multiply to give me 25 and add to give me -10 are -5 and -5. So x minus 5 times x minus 5. And now I can set each factor equal to 0 and solve for x. So I can set 5 equal to 0 and solve for x. There is no x, so you can't do that. I can set x minus 5 equal to 0 and solve for x. I get x equals 5. And then this is giving me the same solution, so I don't have to do it twice. 5, add 4 zeros, and there's your $50,000. Okay? Okay, so This is finding y-intercepts and zeros and x-intercepts. So it says, use the given graph of the function to estimate the y-intercept and any zeros, then confirm the answers algebraically. I think that's a stupid idea. So what I have students do is you find the y-intercepts, x-intercepts, and zeros algebraically, and then confirm using the graph, okay? Because that's what we want you to do. All right, so recall, how do you find y-intercepts? Think of what a y-intercept looks like. 0, 5, 0, negative 6, 0, 80 billion, right? So it's all 0, comma something. So we're going to plug in 0 for x and see what we get for y. So let's plug in 0 for x into our expression right here, and we get 4. Okay, confirm using your graph. Is your y-intercept 0, 4? Voila. X-intercepts. Now it says x-intercepts because there can be more than one. Remember, they are always something comma 0. So you can have this, you can have more than one when it's a parabola. Okay, so I'm going to set y equal to 0 and solve. So that is 0 equals x squared minus 4x plus 4. Can't square root, going to try to factor. There is no GCF. That's x minus 2 times x minus 2. So I get x equals 2. So my x-intercept is 2, 0. This right here, let me just cut this. This is my 0. Okay, so zeros and x-intercepts are very similar. Intercepts are always written as ordered pairs. Zeros are just x equals. So zeros are always just x equals. Okay, let's do the same thing here. Where's my equation? There it is. Okay, so I need to find the y-intercept. So I'm going to plug in 0 for x and see what I get for y. So I'm finding g of 0. So I have the absolute value of 0 plus 2 and then minus 3. 0 plus 2 is 2. The absolute value of 2 is 2. And then minus 3, which is negative 1. 0, negative 1. Yep, that's right. X-intercepts. Set y equal to 0 and solve. Okay. All right, so you had a problem like this in your summer packet. Solving absolute value functions, first thing you have to do is isolate the absolute value. So I'm going to add 3 to both sides. Pay attention to this one, because this is something you probably haven't seen in a while. All right, so now I'm getting the absolute value of this is 3. Okay, so what can that be if the absolute value is 3? It can be 3 or negative 3. So I need to solve 2 equations. X plus 2 equals 3. X plus 2 equals negative 3. I get x equals 1. X equals negative 5. So those are my zeros. Those are my zeros. So I'm just going to grab them, put them right there. And then my x-intercepts are 1, 0, and negative 5, 0. And if you look here, 1, 0, negative 5, 0. Okay? All right. So now we have 4 problems where you have to find the x-intercepts, y-intercepts, and zeros. You're going to have to find x-intercepts, y-intercepts, and zeros for several chapters in the future, and it's just like part of the problem. So make sure you realize you know how to do it no matter what equation it is. Okay, so let's start with y-intercepts. Find y-intercepts, plug in 0 for x, see what you get for y. So I'm going to find f of 0. Plug in 0 for x. That's 0 cubed minus 0. So I got 0. That means my y-intercept is 0, 0. When I plugged in 0 for x, I got 0 for y. Now I'm going to find my zeros and x-intercepts. So to find my zeros and x-intercepts, I'm going to set my function, which is f of x, equal to 0. So I have x cubed minus x. All right, so now I need to solve this. Please don't be that person that says, I don't know how to solve something with a cube. You factor it, okay? You have to try to factor it. It has to be equal 0 in order to do that, but you got to factor it. 0 equals. Remember, when factoring, first thing you ask yourself is there a GCF? There is. It's an x. Then I have x squared minus 1. And now I can set each factor equal to 0. So I can set this equal to 0 and this equal to 0 and solve. X equals 0. X squared minus 1 equals 0. Add 1 to both sides. Do not forget to do square root plus or minus, square root plus or minus. So I get x equals positive and negative 1. So there's 3 zeros. Last but not least, my x-intercepts, it's not any more work. So I have 0, 0, 1, 0, and negative 1, 0. So notice I took each of these x values where y was 0. All right, that's it for the first one. All right, second one, it's good practice. It's a square root function. So I want to find my y-intercept. So I'm going to plug in 0 for x. So I have square root of 0 plus 4 and then minus 5. 0 plus 4 is 4. Square root of 4 is 2. Notice I didn't write plus or minus 2 because the square root of 4 is not plus or minus 2. The square root of 4 is 2. When you're solving like so and you put the square root in, that's when you have to remember to do plus or minus. So here you get negative 3. So my y-intercept is 0, negative 3. X-intercept and zeros are next, so I'm going to set my function equal to 0. 0 equals the square root of x plus 4 minus 5. All right, I need to solve this equation. So realize I have to get rid of this square root by squaring both sides. But before I do that, it has to be isolated. So I'm going to add 5 to both sides. And now I can get rid of my square root by squaring this side, but I got to do it to this side also. 25 equals x plus 4. Subtract 4, x equals 21. This is my 0. X-intercept, 21, comma, 0. Okay. All right, next one. Go ahead and pause the video and try this one on your own. Okay, so y-intercept, plug in 0 for x. So you're plugging in 0 here, here, and here. And you should see you get 0. So your y-intercept is 0, 0. X-intercepts and zeros, set your function equal to 0 and solve. Once again, please do not be the person that says, I don't know how to solve something with a cube in it. You have to get it equal to 0 and factor it. Look for GCF first. They have x in common. So then I have 3x squared minus 10x minus 8. Keep factoring. So I have 0 equals x times. So now I need to factor 3x squared minus 10x minus 8. I'm going to do it in a different color just so that it doesn't get lost here. Ooh. Okay, so I'm looking for two numbers that multiply to give me negative 24 and add to give me negative 10. So you should get your two numbers are, so people accidentally, like from what I remember, people accidentally use negative 6 and negative 4. But that doesn't multiply to give you negative 24. It's negative 12 and 2. Then divide both of those numbers by your leading coefficient, which is 3. This fraction, 3x plus 2, or sorry, 2/3 is not simplifiable, so that's one of your first factors, 3x plus 2. Your other fraction does simplify. So negative 12 over 3 simplifies to negative 4 over 1. So that is x minus 4. All right, now I can find my zeros by setting each factor equal to 0 and solving. So I have x equals 0, 3x plus 2 equals 0, x minus 4 equals 0. Now I'm going to solve for x. The first one's already done. The second one, I'm going to subtract 2. Divide by 3. Last one I'm going to add 4. So here are my 3 zeros. X-intercepts. I have 0 for x when I plugged in 0 for y. I got negative 2/3 for x when I plugged in 0 for y. And I got 4 for x when I plugged in 0 for y. Okay, the very last one. Go Go ahead and pause your video and try this one. All right, let's start with the y-intercept. Plug in 0 for x, see what you get for y. If I plug in 0 here and here, I just get 1. So 0, 1. Find your x-intercepts by setting your function equal to 0 and solving. Okay, it's quadratic. So the first thing I ask myself is, can I solve by square rooting? The answer is no, because there's an x squared and an x. So now I'm going to try to factor it. I need two numbers that multiply to give me 1 and add to give me -4. Not going to happen, so I have to use quadratic formula. So quadratic formula, x equals the opposite of b, so 4, plus or minus the square root of b squared. So notice how I wrote that. The -4 is in parentheses, squared, minus 4 times a times c, all over 2 times a. All right, let's clean this up. 4 plus or minus the square root of 16 minus 4, all over 2. X equals 4 plus or minus the square root of 12, all over 2. Simplify the square root of 12. Root 4 goes in there root 3 times. Root 4 is the same thing as 2, so that simplifies to 2 root 3. X equals 2, oops, not 2, 4 plus or minus 2 root 3 divided by 2. Don't forget to divide this by 2 and this by 2. So this becomes x equals 2 plus or minus root 3. These are your zeros. And then your x-intercepts. You have 2 plus root 3, comma 0, and 2 minus root 3, comma 0. If you just want to write it as 2, oops, got a little too much to erase there, but not a big deal. If you want to write it as 2 plus or minus root 3, comma 0, I'm fine with that too. Okay, that's it for this lesson. Go ahead and try the homework for 1.